Hello and welcome. This is the last part of chapter 9, in which we will be talking about some other excavators, including draglines, clamshells, and gradles. Let's get started. So, about dragline and clamshell. Both of them, as you can see, are hung on a boom crane, okay? But they have different operations. They're good for different purposes. Dragline, as implied by the name, fills its bucket by dragging it on the surface, while a clamshell is, lands vertically on the load and then fills its bucket. As you can see, there is no hydraulic force for either of them, so the weight of the bucket is the only force you have available for crowding. This makes them, so why do we have to, why do we use them? They don't have, you cannot push the load with them. You can just drag the bucket so it could collect some materials in its bucket. So why would we use drag lines almost extensively? Because of their access to, areas that are not accessible by a loader or by other excavators. Most of the time, most importantly, the main use of them would be using them in water, right? So a loader or other excavators, or like, for example, a hoe, many of them do not have the capability to work in water, in deep water, but draglines and clamshells buckets could be sent remotely when the driver is on the coast. They could be sent and do the digging or excavating for us. That's why it's the main idea of using them. Okay. So drag lines, actually dragline and clamshell are both on the, like I said, on the boom crane, but the mechanism of the bucket and also the type of the bucket are different in these two buckets. That's why we have different names for each. Drag lines work with dragging a bucket toward the machine. Yes, so you set it far from the machine and you drag it towards the machine, and as you do that, the bucket gets filled. With both types of excavators, the buckets are attached to the crane by some cables, and the operator has no positive control of the bucket. It means the control is primarily done in just one direction, whether by dragging or the vertical landing of the bucket, and there is not a lot of hydraulic pressure as opposed to a hoe, but like I said, it can reach further surfaces. All right, so if this is not too small, you can see the main parts of a drag line. And in these two videos, let's watch how they work from the operator's view and someone who's watching it from outside. So once again, they're used to excavate it. We're talking about drag lines. You're used to excavate materials and load it into hauling units. Obviously, the materials they can work with should be very soft materials, not tough ones. Most of the time they are they are best to excavate levels that are below the machine level. Okay, so they're not good to be used. They cannot do the job if the excavation level is above where the machine rests. So they can handle, like I said, very soft materials to medium hardness, but obviously not good for trucks because you cannot apply pressure to collect the trucks. The main advantage, the biggest advantage of them is the long reach for digging and dumping, where other excavators or loaders cannot function. It does not have the positive digging force of a hydraulic shovel or row. One weakness is that so working with them is not that easy, because in many times once you fill the bucket, it bounces, it trips over, it drifts sideward, so the load will be emptied before the operator has a chance to unload the bucket. So crawler mounted are good to be used where wheel mounted are not possible to be used, but the machine comes in both forms of wheel mounted and crawler mounted, based primarily based on the surface condition. So the travel speed of a of a dragline is very low. It's even less than 1 mile per hour, because they are giant machines. That's another limitation with them. And it is necessary to use auxiliary hauling equipment, okay, to transport the units, so they cannot travel on their wheels. You have to use another hauling unit to bring them to the side and mobilize the side, and then demobilize it. All right. So what factors impacts a dragline production? Lower the volume. So the factors that can impact a dragline production are the condition of the material, type and condition of the material. Okay, by condition we mean, for example, the moisture content, the reachability, and of course type identifies what material are we dealing with. So depth of the cut will impact the production rate. I'll show it in the next slide that the drag line will work more smoothly in certain range, and after or before that range, its production will decrease. So angle of swing is also important. At certain angles, it can work more smoothly. Size and type of the bucket, obviously, like many other earthwork equipment that have buckets here, the buckets are replaceable. You can change them based on your need. And the length of the boom is also to determine the reachability of the materials. Obviously, the longer it is, you have more reachability reachable zone. But the thing is, operating it could be more difficult, and the ease of movement, especially when you are working in a port where there are a lot of materials, a lot of other objects that you should be careful not to hit, creates additional issues for a very long boom. Method of disposal, casting, and loading also determines the production rate of a drag line. The size of the hauling unit is also important. Obviously, the production, if it is loading a smaller truck, then it will take longer. And of course, the skill of the operator, because these machines are not easy to operate or control, and the skill of the operator matters. Physical condition of the machine and the job conditions are obvious reasons that can impact how productive your machine is. All right, so if you remember, I just said that the drag line could could have different productions depending on how far is the bucket from the machine, or the operator. So as you can see, they are good for working in levels that are lower than the level on which the machine rests, as you can see here. In different ranges, the digging capacity or the digging quality ranges. For example, where it is the closest to the machine, to the operator, we have a poor digging. As you can see, the surface, the touch surface between the bucket and the ground is limited, so you have a poor digging. In a longer distance, after that range, you have a pretty good digging, so it takes 15% more power to lift. However, here, in the first zone, it takes 42% more power to lift, so its fuel consumption also could be impacted depending on how far is the digging area from the operator. The best is where the bucket could almost be, perpendicular to perpendicular to the surface. You get the best digging and the lowest fuel consumption. And after the perpendicular, okay, it means any angle that is wider than 90 degrees, you should avoid casting, because that would be very difficult for the bucket. It means it's almost, it is not effective. You cannot collect materials, or if you can, that would be a very low amount, okay? All right, so based on this, we would have different numbers, and there is a lot of tables with a lot of information about the optimum distance, or where the operator should use. Should put the machine or should put the bucket accordingly based on these numbers. So I won't get into that much detail in this part. So if you remember, we talked about the second thing we talked about was clamshells that would land vertically on a surface. So here, let's see how they work. So the holding, closing, and tag lines control the bucket. Holding, closing, and tag lines. At the start, the bucket should rest on the material to be dug, and its shells are wide open. And then the two shells of the bucket are down together, causing them to dig into the material. Okay, that's why your material should be soft, because if they are not soft enough, the weight of the bucket cannot create enough pressure to force the material, to be loaded on the bucket. And the weight of the bucket is the only crowding action, like I said before. After the bucket is closed, the holding and closing lines raise the bucket, as you just saw, and swing to the dumping point. And at the last step, you dump by releasing the tension on the closing line. Okay. So as you can see, for both draglines and clamshells, one of the main usages is where you have water. You have to do excavation in water, where accessibility is limited for other types of excavators. Otherwise, they don't have a lot of power. There is no hydraulic power, which is a very important weakness of these machines. All right, so I didn't want you to lose that. Okay, so let's talk more about clamshell excavators. So they have a vertically operated bucket. The clamshell bucket consists of two opposing scoops hinged together. As you can see, This is not in fact a clamshell. This is a clamshell bucket, because in clamshells we mainly mean the bucket that is hung to a boom of a crane, okay? But sometimes, I mean, with some machines, you can replace their bucket with these buckets, with a clamshell bucket for different operations. And obviously, the accessibility is a lot less than clamshell that is hung on a boom. But the good thing is that they can apply force and they can work with more stiff or hard materials. So clamshells are used primarily to handle materials such as loose to medium, including sand, gravel, crushed stone, coal, and shells. They could also be used to remove materials from vertical excavations. Okay, let's talk about Gradalls, the last excavator we cover in this chapter. So they combine the operations of a hoe, a dragline, and a motor grader. The wheel ones are pretty fast. They can move in highway with the speed of 55, so they don't need another machine, another hauling equipment to bring them to the site. They could be mounted on crawler tracks or wheels. They're good for excavating and finishing work. Yeah, they have a lot of additional capabilities in terms of reaching restricted working zones compared with other excavators. That's why here you see they're, when working with water, they're getting used. So obviously their production is not as much as a hoe. Hoe has a higher production. They can perform dragline type operations, but a dragline would cover a wider, area compared with a Gradall. So the greatest advantage of them is the hydraulic control power, which enables the machine to work with stiffer materials and shaping the slopes. So at the end of this presentation, I have put some nice videos. It's not part of the course, but you can watch them. They're about future heavy equipment, how it is expected that the equipment change in the future, massive earth-moving machines, so which familiarize you with some of the giants in this industry, and some breathtaking skills of operators. Okay. All right, that completes our lecture today. And I see you guys next time.